All right, so let's see, 15 more is going to be 240. I'll do this kind of fast. 270. All right, 315, 330. And now this really makes sense that this is now 360 all the way around. All right, now the radians here, what you have to do on your radians is kind of difficult because radians are usually harder. All right, now let's go from the radians, especially the conversion factor that we should know. Okay, what's that conversion factor that we've used to convert? Right, 180 degrees is pi radians. So we're not going to write it just yet. Okay, just go with me. This is pi, and so halfway to halfway right there would be pi over 2, half of pi. Okay, now what would be half of half right here? Pi over 4. Okay, so 45 degrees is pi over 4. Now that's one of those that you got to memorize. Okay, so kind of at the top of your paper right here, that what 45 degrees is pi over 4. Okay, now of course 0 degrees is 0 radians. Okay, now what we're going to do is count by pi over 4s for every 45 degrees. So every 45 degrees is a pi over 4. Right, so we're counting by pi's over 4. All right, so this is 0, and this is pi over 4. So now 45 more degrees would put me at 90. And so that would be 2 pi over 4, which is pi over 2. And we figured that out earlier, right? Pi over 2. Now it makes sense, doesn't it? All right, so every 45 degrees is a pi over 4. So pi over 4, 2 pi over 4. Another 45 degrees would put us here, wouldn't it? So it'd be 3 pi over 4. And then another 45 degrees would be 4 pi over 4, which is just pi. Because we're counting by pi over 4s. Pi over 4, 2 pi over 4, 3 pi over 4. All right. Now, so you should be able to tell me what this one is down here. 5 pi over 4. Another 45 degrees is going to put me at, yeah, so it would be 6 pi over 4, which would be really 3 pi over 2. You can use it as the blank or the fraction bar. It don't matter. I mean, y'all aren't going to get that anyway. So. Okay. So I'm going to show dual enrollment how to draw it without, just draw it from the blank sheet of paper. Okay. It's not really that difficult. Now, let's see, where we leave off right here. All right, that was 5 pi over 4, so this would be 6 pi over 4, so this one would be 7 pi over 4. And now, finally, 8 pi over 4 is 2 pi. And what? 2 pi is 360 degrees. Okay, so you got to remember, every 45 degrees is pi over 4. So when you do your unit circle, you start with your degrees first, and then you do the radians. And the first radians that you do are your pi over 4s. Now, the other one that we're going to do are our pi over, or our 30 degrees. Let me write this at the top for you. Okay, so 30 degrees equals, okay, now look on the board here where I converted 30 degrees. All right, remember how we can convert degrees to radians? So I used my conversion factor, pi radians and 180 degrees, and notice what 30 degrees is. Pi over 6, that's the other one I got to memorize. See, there's really 3 unit conversions you got to memorize. Pi is 180, pi over 4 is 45, and pi over 6 is 30. So at 30 degrees, this is going to be pi over 6. So every 30 degrees is a pi over 6. Okay, so all right, you look on the board at my conversion. All right, 30 degrees. All right, we're switching it to radians, right? So we put like pi radians over 180, the degrees cancel. So you get 30 pi over 180. 30 pi over 180 is going to reduce to pi over 6. Okay? So one thing about it is if you happen to forget these, and you know this one, you can always convert. Okay? Now, so every 30 degrees is pi over 6. What's going to be 30 more degrees from here? It's not going to be 45. It's going to be at 60. Okay, so this one's pi over 6. So 60 is going to be 2 pi over 6, which is pi over 3. All right, so another 30 degrees is going to put you at 90. Even though we got 90, we're going to say it. All right, pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. And so now this one's going to be 4 pi over 6, which is, I started writing it, 2 pi over 3. All right, look, we're counting by pi over 6. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. All right, and so now this one's going to be 5 pi over 6. And then this one would be 6 pi over 6. All right, so now that one was 6 pi over 6. This one's going to be 7 pi over 6. And then 8 pi over 6 would be 4 pi over 3. And this one would be 9 pi over 6, which is 3 pi over 2. And then 10 pi over 6 would be 5 pi over 3. I got lost. What was this one again? 10 pi over 6? That's 10 pi over 6, so this one would be 11 pi over 6. Right, you can go back to these, and I get lost a lot, especially when I have to reduce it. I forget. When I reduce it, I forgot what it was. Okay, now, all right, y'all see how the radians work now? So remember the one that you start with is the 45s. Every 45 is pi over 4, and then every 30 is pi over 6. Okay, and you just count around. You don't memorize, you count around. Okay, yeah. Well, by the end of the semester, some of you won't even have to draw it in dual enrollment. You'll have it so ingrained, and usually after about a month of it, I don't have to draw it anymore or look at it. I can tell you anything on it. Okay, because you just use it so much. Now, let's fill in the ordered pairs. Okay, now the ordered pairs are going to come in from a couple of triangles that I'm going to use. Okay, so let me do this. All right, so these they're called the special right triangles in geometry. The 30, 60, 90. You don't have to, because I'm going to really give you a better way to remember it in just a minute. Okay, so this is going to be my 30, 60, 90, and then my 45, 45, 90. Now, the unit triangle here for the 30, 60, 90 is you do 1, 2, square root of 3. Okay, so this is 1, 2, square root of 3. And then the 45, 45, 90 is 1, 1, square root of 2. Now, here's the other important thing that you need to write down. Write down like on the top left-hand corner. We got some room up there. All right. In these ordered pairs, the cosine of the angle is the x-coordinate. Okay, cosine is the x-coordinate. And then the sine of the angle is the y-coordinate. I don't know. I know normally that does throw you off, because normally when we say the functions, we say sine, cosine, tangent, and it's backwards in what we do. Okay, and probably in like a month or so, you'll forget which one's x, which one's y, and then I'll holler at you because you've asked it like 15 times. Okay, and I get impatient. All right, cosine is x, sine is y, and for some reason that's really hard to remember. Now, let's go back, and the way that I'm going to get these ordered pairs, because this is the x and this is the y. So the x is the cosine of the angle. So this angle at this ordered pair is 30. Okay, so I'm going to use my 30, 60, 90 triangles and figure out what would be the cosine of my 30 degrees. Now, what was cosine again? Adjacent over hypotenuse. So the cosine is going to be square root of 3 over 2. And the cosine is the x-coordinate. So square root of 3 over 2. All right, I'll give you a better way to remember it in a minute. I just you need to see where these numbers come from. Okay. Now, the y coordinate comes from the sine. Okay, so what's the sine of 30 degrees over here? What's the sine? Opposite over hypotenuse, so yeah, 1/2. Okay, now let's do 45. All right. No, I'm going to give you a better way. Okay. Now you can do it by your triangles, but I'm going to show you a little trick in just a minute. Okay. The reason why I'm doing the triangles is so you can see where these numbers come from. Now, 45 degrees, you're going to go to your 45, 45, 90. Now, remember what the x-coordinate is? The x-coordinate is the, which one? Cosine. Okay, so what's going to be the cosine of a 45 on here? 1 over the square root of 2. Now, you need to rationalize that. So write it down over there. 1 over square root of 2 would be square root of 2 over 2. All right, now, this one is the y-coordinate, or the sine. So the sine of 45 degrees is opposite over hypotenuse, which is the same thing, isn't it? So 1 over square root of 2, and it would go to square root of 2 over 2. All right. Now, let's go to the 60 angle. So now I'm back on my 30, 60, 90. All right. So the x-coordinate is what of the angle? What of 60? Cosine. Okay. So cosine of 60 is adjacent over hypotenuse. Yeah, so 1 over 2. And then the y-coordinate is the sine of 60. The sine of 60 will be opposite over hypotenuse, so square root of 3 over 2. Okay, now it seems like that's kind of complicated to learn. It's really not. Okay, watch. Notice they're the same numbers here and here, aren't they? But they're just switched. So if you memorize this one, all you have to do is just remember to flip it right there. What do you notice about these two? They're the same. Okay, so really all you have to do is learn 3 ratios: 1/2, square root of 3 over 2, and square root of 2 over 2. Okay, now here's probably the best way to understand. All right, question, go ahead. All right, we'll talk about that in a minute. Okay, now let me show you another way I've learned how to do the ordered pairs. And this is the little trick I'm talking about where you don't really need the triangles. Okay, so let me do it on a different sheet to kind of show you here. All right, what do you notice about all the denominators? They're all 2's. Okay, so let me start over here. So you go through and you fill in every denominator with 2. Okay, now you're going to start at the top and you're just going to count. Watch, I'm going to go 1, 2, 3, but you got to start at the top, okay? So 1, 2, 3, and then I'm going to count back up. 1, 2, 3. And now I'm going to take the square root of every numerator. But what? The square root of 1 is 1. But see, this would be square root of 3 over 2. Take the square roots on the numerators there, square roots of 2 over 2 on both of those. Take square root here on 3. Now, here again, though, the square root of 1 is 1, so I wouldn't do it on that one. There you go. Now, I saw that on YouTube. Okay? So, and so, you know, yeah, I didn't figure that out. Now, here's the way I used to do it. All right, when I figured it out, I would look at it this way. This distance right here is your x, isn't it? And then this distance is the y. Now you notice that the x distance right here is longer. Well, square root of 3 over 2 is bigger than 1/2. Okay? That's the way I remembered it. Okay, because this is a longer distance. That's going to be the square root of 3 over 2 on the x. Now, all right. Now, what about, all right, Katie, what you asking about the other parts here? How do we get the other ordered pairs, though? All right. All right, how you do it? Hmm? same numbers go over here? Exactly. Same numbers? Right. Some of them are going to be negative. Okay. So here's what's going to happen. We're going to take these points and we're going to reflect them across the y-axis. And so when I reflect across the y-axis, the negatives or the x's will be negatives. Okay. So 30 degrees would reflect on top of what angle? 150. Okay. So these are going to be the same numbers, except for the x coordinate is going to be negative. So it's going to be negative square root of 3 over 2. Now, would the 1/2 change to negative? No. Okay. So now the pi over 4 is going to reflect over to 3 pi over 4. And so now this one's just going to be negative right there. Square root of 2 over 2 and square root of 2 over 2. All right, let's reflect this one over. All right, so y'all tell me what this one's going to be now. Yeah, negative 1/2. Yeah, square root of 3 over 2. Okay, so the thing is, on the ordered pairs, all you really have to know how to do is the first quadrant, right? Because you can reflect to get the other ones. Now, down here in my third quadrant, right, both of them are going to, because what I can do is just take these and reflect them across the x-axis. So when I reflect across the x-axis, all the y ones here are going to change to negative. So all of them down here are negative. Okay, so let's see. Now, what reflects on top of 210 though? Is it going to be the 150 or the 120? 150. So that's where a lot of people mess up when they reflect. Is they, for some reason, they take that one and go, but it's 150 would go to 210. So now, both of them are going to be negative now. Square root of 3 over 2 and negative 1/2. Okay, now call this one out for me. All right. This one's going to be from the 120. All right. Negative square root of 3 over 2. All right. Now, on the fourth quadrant, you can take these 3 points and reflect them across the y, like that. Or, what's probably better, instead of reflecting those, yeah, the first quadrant ones, and reflect them down. So when these reflect down across the x-axis, you would change the signs of the y's. So all the x's would stay the same, and all the y's would become negative. Yes? These right here, okay, by taking this point and reflecting it down here. So when I reflect this point down here, when I reflect across the no, right above, okay, so these reflect down. So don't use the first quadrant to get the third, okay? Use the second quadrant to get the third quadrant. Now, let me write these in real quick. All right, so I'm going to reflect this one down. So it's going to be square root of 3 over 2 and then negative 1/2. All right, this one would be square root of 2 over 2 and then negative square root of 2 over 2. And this one's going to be 1/2 and then negative square root of 3 over 2. Now, the other ordered pairs, notice that we haven't finished all of them. Remember I said earlier that the unit circle has a radius of 1 unit? Okay, so you're just going 1 unit. So what's this going to be right here? 1 unit to the right. Yeah, 1, 0. Okay, 0, 1. All right, right. 1, 0. 0, yeah, negative 1 at the bottom. All right, now let's see, what else do we have to fill in? All right, what is this positive, negative stuff that we're talking about? All right, and now dual enrollment, I tell you this, sometimes there might be some tests where you won't need the degrees. So you just leave off the degree measures when you do it out, okay? There's some maybe tests where you don't need the radians, okay? Now, and And what I would do when I copy mine down, I only do the first quadrant when I do mine because I can figure out and reflect, get the others. Now, let's talk about well, the positive, negative. What they want us to do right here when they say fill in the unit circle is they want me to tell them which trig functions are positive and which trig functions are negative. Now remember we have 6 trig functions, sine, cosine, tangent, and then their reciprocals, which are cosecant, secant, and cotangent. All right, now there's a little mnemonic device, kind of like what some old hippie called another hippie tripping on acid. There's one like this, and it goes like this. And we'll write the letters above positive and negative here. It's this, it's A for all, S for seniors, T for take, and then C for calculus. Okay, so you say all seniors take calculus. Okay, now it's just something to help you remember. Another one is like all seniors take chemistry, but no, hardly any of you seniors take chemistry. Or this is chemistry too. All right, now, so what this tells me is this letter tells me which ones are positive. So which ones are positive in the first quadrant? All of them, all 6 of them. So you don't have to list all 6. You can just write all. And so which ones are negative? None. Okay, if all of them are positive, then none of them are negative. Yeah, each quadrant. Okay, and usually like in honors last year, when they'd fill it in, there'd be somebody over here that was sleeping, and they would fill in the unit circle perfectly. She's not watching. And she would always forget to fill in positive or negative, and she'd get it wrong every time. Poor thing, and she's still going to get it wrong. Poor Hannah. All right, she's tired. All right, here we go. All seniors. Now, again, this is going to tell me which one's positive. Sine. Okay, now, if sine is positive, then now you got to think a little bit. If sine is positive, the reciprocal would also be positive. So if sine is positive, then cosecant is positive. Does that make sense? You really figured that out. All right, S is for sine. So if sine is positive, then the reciprocal of sine is also positive. So if sine is positive, cosecant is positive. Now, which ones are negative? The rest of them. So let's list the rest of them, which would be cosine, secant, all right, yeah, tangent, and cotangent. All right, now, so in the third quadrant, guess what T stands for? Because this is going to help you later. Okay, all this stuff is going to help you tremendously later. Okay, now, which ones are positive in the third? T stands for tangent. So if tangent is positive, so is cotangent. So which ones are negative? The other 4, which would be, all right, what? Sine, cosecant, all right, what else? Cosine, and secant. And look at it this way. You remember what we said that the x-coordinate was cosine and the y-coordinate was sine? They're all negative, aren't they? We'll talk about later how come tangent gets to be positive. Now, on this one, let's see. Here we go. Let's go back over here. What? All seniors take calculus. Okay. Oh, that's a good one. All seniors take charge. All right. So C stands for cosine being positive. So if cosine is positive, so is secant. All right. So which ones are negative? Sine, cosecant, tangent, and cotangent. All right. So if you know the positive ones, by default, the rest of them are negative. Okay. Now, let's do this.